Systems of equations, solve by graphing. This is example number 3. Okay, so again, we need to make sure we solve for y. The first equation is already solved, so that's great. Second equation, I need to solve for y. So let's take a look at the second equation. What I'll do is just recopy it. Y plus x equals -5. In order to solve for y, we subtract x from both sides. So let's do that. Which gives us y equals, again, I like to write x first, minus x minus 5. So here we have our second equation. And like before, I will make the first equation red and the second equation green. That way we tell the difference between the two. Let's start with the first equation. So our y-intercept is going to be 1, so 0, 1. That's going to be right here. And our slope is 1, which means up 1 to the right 1, up 1 to the right 1, up 1 to the right 1. Remember, I know that the first line and the second line, they're not parallel, which means that they have to intersect. If they were parallel, they would have to have the same slope, which they don't. So I know that they will intersect. There is a solution. So we continue. Now, there's another way to get our points from the slope. Instead of going up 1 to the right 1, you can also go from your y-intercept. We can also go down 1 and we can go to the right 1. And sometimes, or down 1 to the left 1. Sometimes that's helpful, as you'll see in this case. So I'm going to do this again. I'm going to go down 1 to the right 1, and let's do it one more time. Down 1 to the right 1. Because I need to get points on this side of the graph. If we continue going up 1 to the right 1, up 1 to the right 1, we will just get points on the right side. I need to get points on the left side, as you'll see. Before we connect, let's look at the second line. The y-intercept is 0, -5. 1, 2, 3, 4, 5 right here. The slope is -1, which what we've done before, it would be down 1 to the right 1. Down 1 to the right 1. You can tell that the lines are going to intersect somewhere here. If I keep going down 1 to the right 1, I will not get points on this side of the graph. So what we're going to do is, instead of down 1 to the right 1, the opposite would be from the y-intercept. Up 1 to the left 1. Up 1 to the left 1. Up 1 to the left 1. And that will give me points on the left side of the graph. You can use both methods. It depends on the problem. In this case, we had to use the second method so that we get points on the right. And you can quickly tell that the two lines will intersect at -3, -2. And we're going to check our work in a second. Let's connect our dots. I hope you guys can see this. Okay, so we have our two lines. The solution would be where they intersect. And so our solution would be right here. And we need to write the ordered pair, which we said is -3, -2. Okay, so that's our solution, but we want to make sure this is correct. So you check your work like we did in the first example. we take the solution, substitute it into both equations. Now, you can use the original 2, or I can use the first, and I can use the one that's solved for y. I'm going to use y equals 2x plus 1, y equals negative x minus 5. I think it's just easier. So y equals x plus 1. Let's check. Replace y with negative 2. Is negative 2 equal to negative 3 plus 1? It does look like it is. Negative 2 equals negative 2. So it works for the first equation. Check the second equation. Y equals negative x minus 5. Replace y with negative 2. Is that equal to negative 3, be careful with that, minus 5. Negative 3 is 3, minus 5. Looks like negative 2 is equal to negative 2. It works for both equations, therefore the solution's correct. Remember, it has to work for both. You can always check your answer this way, no matter what method you're using to solve.